So in this session, I'm going to go through the first homework on the discrete random variables, and I'm also going to show you how you could use Excel to simplify some of the arithmetic from that homework. And then I think I'll go a little beyond the homework. There's a problem here where you have to find the mean of the distribution, but I think I'll also do the standard deviation just to help with picking the right formula from our table of formulas and substituting the numbers in. So I'm looking at this example. Maybe I can make that a little bit bigger. So X is the number of rooms in a randomly selected owner-occupied housing unit in San Jose. X is a discrete random variable because you only ever have a whole number of rooms. And here's a probability model. Okay, so the experiment that we imagine here is you pick one randomly selected room, one randomly selected housing unit in San Jose, and then you see how many rooms does it have. And that's an experiment that you could do over and over again. It's a repeatable experiment. And this probability model is predicting that 3 times out of 1,000 in the long run, you'll find that the apartment has 1 room. Okay. And so this probability model, it's not necessarily based on real data. It's somebody's theory for what they think will happen. It may be based on data that was collected in the past, but what makes it probability instead of just a frequency table or percent frequency table is that this is a prediction for experiments that could be repeated in principle. Okay. Now, the problem about to find the probability that X is greater than 5, well, actually the question was just asking you to write that out in a sentence, okay? And so I'm going to write over here. And I just want to emphasize sort of how you approach a question that's asking you to interpret something in context, because some of the answers that I got were not what you call in context. And it's good to know what that phrase means, for standardized tests also. So let me put up the paper over here. And so the question was, to interpret P X greater than 5 in context. Okay. So what that means is you go through and you just replace each symbol with what it means in this story. The context is like this particular story. So P stands for the probability. So the probability that X will be greater than 5, and you just have to replace the X with what it is. X is the number of rooms in a randomly selected owner-occupied housing unit in San Jose. That's what X stands for, so you replace the X with that. Okay, so I replaced the P with the word probability. I replaced X with the phrase that it stands for. The next symbol that I see is greater than. And then 5. Okay, so that's how you do that one. Now let's see. Find the probability that X is greater than 8. So 5.3% of the time, X is 9. And 3.5% of the time, X is 10. So you add those together, and that's what percent of the time X will be greater than 8. So it's 0.035 plus 0.053. So I get 0.088. Okay. Now, find the mean. So this is where some of you got lost. So I want to make sure you know where the formulas are here. We go back, and in the discussion, the discussion in the workbook is not real detailed. It just says I'll compare and contrast these formulas and tell you where they come from. And so there's a video where I do that, and then here's the summary, this table in the workbook. And we want the mean of this probability distribution. So we're over here, we're in this column. It's not X bar, that would be a sample mean from real data. There's no data here. This is just a probability model. And so we're looking for this formula here. So what I do is, oh, I didn't show you. Here's the workbook. Let me get the whole screen up here. So here, this is the workbook, and there's just the discussion back here. That's not very detailed. It just tells you what it is we're doing. That we're going to get the formulas for mean and standard deviation of a probability distribution, and then it gives you this table where we have our formulas back from the unit on exploratory data analysis, where we have the mean and standard deviation for raw data or a frequency table. And the new thing is for a probability model. And so if we're using this formula for mu. So in the current homework problem, what that means is, well, we start out with j equal 1, and we get P1 times X1. And then we let j equal 2, we get P2 times X2, and we add them all up. So that's P1 X1 plus P2 X2, and so forth, all the way out to P10 X10. And now, so you can look at the table, and you have 0.003 times 1. And then 0.002 times 2. And we'll keep going all the way down to the bottom, 0.035 times 10. And so the easy way to do the arithmetic, when you got that much adding and multiplying to do, the easy way is to use Excel. And so here I've got the list of all the numbers in Excel. I just need to do the P1 times X1 and P2 times X2. So let's see. So I'll say equals to make a formula. I'll do my P1, and then the asterisk is multiplication. So I have P1 times that first X value over there, one room. Okay. And so this is a number of rooms, right? It's 0.003 times the number of rooms. Okay. And then the nice thing about Excel, when you copy and paste, it adjusts the entries to go by relative position. So, it's take the guy next to me and multiply it by the guy next to him. So I don't have to keep typing. In fact, I don't even have to keep on with the copy and paste. I can grab the little corner of the cell and drag it down, and it'll do all of them. And then to work out the sum, if you look over here in the image on the paper, I'm just adding all those together. So to make the mean, what I'm going to do is I'm going to say equals. I'm going to make the sum, SUM, and select the ones I want to add together. There they are. Close the parentheses, say enter. And I get my mean is 6.284 rooms. Okay. Now, the homework exercise does not do the standard deviation. Does not ask you for that, but I'm going to go ahead and do it because now that we've got Excel set up here, it's quick and easy, and you can get a little review of these formulas. So I go back up to my table of formulas here, and so this is the standard deviation for a probability distribution. And in the other videos, there were some lecture videos where I derived that. Okay, so there's a long discussion about why it is what it is. Okay, but it basically it's a matter of replacing looking at what you would do with a frequency distribution and replacing the percent frequency divided by the sample size. Take that ratio and replace it with a p. And there's a little trickiness about why when it's a sample, it's n-1, and with the real with the whole population, it would be a capital N. But the p is doing what you think would be right for the whole population. Okay. So here's our formula. And this was the definition formula. Now, in one of those lectures, I did work out a shortcut formula. We could do some algebra and rearrange this thing to make something that's a little less arithmetic. But, you know, I think since I'm doing the arithmetic with Excel anyway, there's not much reason to go to the shortcut formula. So we don't have to think about it right now. I'll just stick with this one that I've got. So I'm going to take each one of these xj's. Well, let me write out a few terms so you'll see what this is. Okay, so this is what it is that we're doing. It's for every one of these x values, we got to subtract the x value from the mu and then square it and then multiply by p. So I'm going to start with Excel. I'm going to get all those, do all that subtracting. I'm going to do x1 minus mu and x2 minus mu and so forth. So I'm going to make a column over here. xj minus mu. All right. So here's x1 minus mu. And when I copy and paste, it's going to do the wrong thing at first. Let me show you what happens when you copy and paste. See, it made the adjustment. So up here it was x1 minus mu minus d44. That's the location where mu is. Okay. And when I copied and pasted, see, it moved down to the next x value, which was good. It also moved down instead of d44. Now it's d45, but that's not what I want. I still want the mu. I still want d44. So what I do, delete that, is I can change the copy and paste behavior. I can put a little $sign here, and then it means literally d44, don't change when you copy. And keep that part the same. And now when I copy and paste, see, it kept the d44 literally d44, but it adjusted. It changed the C30 into C31. Okay. So now it's doing the right thing. So I get all those differences. And then looking over here at the formula, I need to square them. I need to square each of the xj minus mu's. So so to do that in Excel, I'm going to say equals. And I want this guy, this difference, to the second power. I use the little caret symbol. It's the capitalized 6 on the keyboard. And so I get that. I don't need to show so many digits. Doesn't really matter how many I show, but it's just kind of silly to show that much. And then drag that down. So I get all the xj minus mu's. And then now I need to multiply those times the pj's. So I'm going to take each one of these guys times his probability. Okay. And so then to get sigma, the standard deviation, I need to take the square root of what you get when you add all these together. So I'll do square root of the sum of all these numbers. All right. And so the standard deviation is 1.640 rooms. So if you got a bunch of rooms and you want to know, like, on average, how far, how you get a bunch of apartments, owner-occupied housing units, and then you say, okay, on average, when you look at one of these, how far from average do you expect it to be, right? And so it's like the average distance away from the mean. And so we have this probability model for what we may get in the future if we go and collect real data. And this is saying, okay, if the model's right, then here's what you would get. Okay. So I think that does it for going over the homework one. I want to go back to the topic in the workbook. And take a look at the second homework here. It's about the coin flipping and the basketball shots. Okay. And I think what I will do, I'm gonna put that in a separate video. What these things have in common is whether you're shooting the free throws or you're flipping the coin, there's only two alternatives, you know, heads or tails, or hit versus miss. Okay, and so we can talk about all problems of that type together. So I'll do these from the homework, and then I'll carry it one step further to learn about the binomial distribution to cover all problems of that type. So we'll save that for the next video. All right.